Hi, I'm Lance Cottrell, Chief Scientist at Ntrepid, and today I want to talk about a new methodology that we've developed for threat modeling managed attribution solutions. Threat modeling is a core discipline for security. It's a key way that you ensure that the systems you develop will be secure against attackers and hackers, that they'll maintain confidentiality, integrity, and availability. But it's not the same as the things you need to look for with managed attribution solutions. For example, in a security system, identification is usually something you're looking for. You want to be able to identify users and visitors. However, in managed attribution, being identified is the worst case failure mode and something absolutely to be avoided. To address this, we at Ntrepid have been developing a methodology for threat modeling managed attribution solutions, specifically looking at the threats that are unique to that kind of operation. Now, as you're watching this video, you might want to take a look at some documents that we've created, and I've got a link so you can download those in the description of this video. So let's start off by looking at traditional threat modeling, and there's a set of threats that people usually look at. I like this STRIDE methodology, and STRIDE's an acronym, and it stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privileges. These are the core threats that any IT system is subject to, and you want to look at all the elements in your solution and make sure you mitigate against them. Well, we've developed a very similar set of threats for misattributed solutions, and we call it CAKED. Now, CAKED is also an acronym, and it stands for Correlation of Entities, Attribution of Actors, Knowledge of Operations, Exposure of Aliases, and Discovery of Resources. And we think those describe well the full set of threats that any managed attribution operation is exposed to. So by correlation of entities, we mean that an attacker is able to connect dots that aren't supposed to be connected, be able to see that two different aliases out on the internet are actually being run by the same operator, or that two different servers that were purchased putatively by different entities actually were paid for out of the same source of funds, out of the same bank account or the same Bitcoin wallet. Right? Anytime an opponent can put together two things that they're not supposed to be able to connect, that's correlation of entities. Attribution of actors is where they can work out who's the person behind the aliases and the entities, actually getting through to either seeing who's the managed attribution service provider, or even worse, who's the end user, who's the operator behind the scenes conducting these operations. And that, of course, protecting that is the whole purpose of running managed attribution situations. Knowledge of operations is where a target or other entity becomes aware that a misattributed activity is taking place. They may not know who's involved. Probably they may be able to guess why, but just knowing that an operation is taking place can compromise that operation. People will start taking countermeasures. They'll start behaving differently. They'll start trying to cover their tracks more thoroughly. Exposure of aliases is where an opponent is able to identify an alias as an alias. In other words, they've seen through the veil and realized that this person they're conversing with isn't a real person in the real world, but is some manufactured identity that is being operated by someone else behind the scenes. And just discovering that can, again, destroy an operation, although they don't necessarily know from that whether this is some sort of a large organizational effort or just some individual that's created this identity that they're interacting with. And finally, there's discovery of resources. And this is where an opponent is able to see a pattern in the way you purchase the visible infrastructure that's connecting out to the world. Typically the exit point in your network, but it could also be servers or anything else. If there's a pattern in how they're created and how they're configured, an opponent might be able to see that from the outside. And if they can recognize it in one server, they might be able to then search the internet looking for other similar servers, and therefore be able to discover numerous elements of your infrastructure. So who's doing these attacks? We look at different classes of threat actor. And in this case, we've got 4 that we break down the entire universe of possible attackers into. And the first is the unprivileged observer. This is anyone on the internet could be a threat to your operation. And they don't have any kind of special access to your data. They're just looking at public postings. They're looking at publicly visible IP addresses and server configurations. Anything that can be seen from someone with a random point on the internet just scanning and watching public information. That's the unprivileged observer threat actor. The next step up is what I call the on-the-wire threat actor. This is someone who is able to intercept traffic. And they might just be, say, an ISP that can watch the connection between you and your relay node, or an exit node and your target, and see that information and draw conclusions from it. But they also might be in a position to see more than that. Perhaps they can bridge over one of your nodes, so they can see both the incoming and outgoing traffic, which reduces the protection provided by that node substantially. The next threat actor I looked at is the one who's on the device. So someone who actually has control of one of these servers. It could be a social media server, someone inside one of these big social media companies. It could be someone that has hacked one of the relays in the managed attribution network, or indeed the company that's operating those. If these are virtual private servers, the company that's hosting those would probably be able to get on the device kind of access to it. And then the question is, would they, and what's your level of trust, and does it matter? And then finally, there's in the conversation. This is either your target, the person you're conversing directly with if you're engaging, or anyone else maybe in a chat room who has access to that discussion. And what's special about that is they get full clear text access to all the communications. They often get all the metadata that you may be sending. It could be the EXIF information on a picture you send, or all the headers in an email. So even if all of your communications are end-to-end encrypted, the person in the conversation gets that in the clear. And that may give them different kinds of available information and evidence and insight to uncover your aliases. So when I'm going to look at a solution, the first thing I want to do is draw a diagram. And so here over my shoulder is a very simple diagram of a very simplified managed attribution solution. But you can see that there's a number of elements. There's network connections between the operator, the managed attribution service, some kind of an exit point relay, maybe an internet server, and the target. And at each one of those links, there could be someone on the wire watching. At each one of those points, it's possible that there is a hacker that has access to the device. Of course, the target is in the communication. And so you want to look at each one of the threats, attach that to each one of those elements, and then look at which of the threat actors in that list might have access to that to understand, okay, what is put at risk by this person from this perspective, looking at the data they have access to. And for each one of the threats then, you can say, do we have a mitigation in place? Is the architecture already protecting us against that? Are there mitigations we want to put in place? Do we need to do some re-architecture to further strengthen the managed attribution solution we have in place? Or do we want to accept that threat? You know, perhaps if, yes, some correlation data might be visible to a US ISP run by a government-friendly internet service provider company, well, that is a risk, and you should note it. You want to know exactly all of the risks that you are explicitly accepting, but that might be a risk that you are willing to accept, because at the end of the day, there's a lot of operations to run, and absolutely mitigating absolutely all of the possible threats out there from every possible threat actor can quickly make solutions prohibitively expensive. And so, as is always the case with any kind of security analysis, you need to be carefully analyzing what are those trade-offs and where can you put your dollars and your effort and your time that will have the maximum impact on the effectiveness and chances of success of your particular operation. Now, one thing I've seen is that a lot of people, in looking at managed attribution, they get focused on just the technical internet aspects. They are really worried about hiding their IP address and hiding their operating system or cookies or things like that. and they forget to look at all the other kinds of identifiers that can expose them. And I did an entire episode earlier just talking about non-technical misattribution and all the aspects that go into that. But I think of it in terms of 5 different domains that we should look at when thinking about all of these threats. And the first is the internet communication. Right? You do need to nail that down. Make sure that you're not leaking any identifiers to anyone you care about that would allow them to expose any of those core caked risks. Beyond that, you might think about, are there phone elements or SMS elements to your communications? Are you using text messaging to, for example, authenticate a social media account that you set up? If the social media company is part of your threat model, or if that phone number might be visible to any of the other entities you're working with, that then also needs to be looked at and mitigated. You pay attention to not just the internet components, but the secondary authenticators and out-of-band communications you might be engaging in. There may be financial transactions involved, either in acquiring some of the infrastructure that you're using, and when you're setting up an exit node or a relay node, how's that purchased? And what does that say about who might be behind the curtain? And do you care? Right. Again, you can put in an infinite number of layers into these things, but it's important to understand at what point do you have diminishing returns, what are the important trade-offs. But financial trails very commonly trip people up, as we saw with the Russia hackers of the DNC and their poor tradecraft in using cryptocurrency, particularly Bitcoin. You also have to think about physical infrastructure. So, do you have physical servers that you're purchasing? Or do you have a data center somewhere, or a cage, or an apartment, or a business office? All of those things are areas that can be exposed. And if you have any of them, you need to consider them. And of course, all of these domains become interwoven, right? You may be using online communications, emails to communicate with the data center where you need to lease the server, and then you need financial mechanisms to pay for that server. So all of these tie together in a complex braid. And finally, we have virtual infrastructure. Are there accounts you need to set up? Are there cloud resources that you need to get? Are there domain names you need to acquire? There's a lot of non-physical resources that also come into play with many of these kinds of solutions, and all of the interactions involved with getting those and how those appear in the world also need to be appropriately covered off. So the process then is to draw up your diagram of the existing solution as you imagine it. Look at each one of the elements in that solution and consider which of the threat actors could be threatening that element. For each of those threat actors, look at each one of the threats, all of the caked elements, and say, are any of those going to cause a problem? And then iterate that process. Right? Is that something that you need to mitigate? Have you already mitigated it? Do you need to re-architect around that? Are you going to accept it and document that? And if you need to do re-architecture, then you update the diagram and iterate the whole process again, going through looking at all of the new elements, the new connections, the new aspects that you've put in place, and how are those affected. And make sure you look at it for each one of those domains to make sure that you're not missing a whole aspect of your operation and leaving that unmitigated and completely unprotected and exposing you to all of those risks. Right? At the worst case, you'd never want to have any of those lead to the attribution of the actual operator in the activity they're conducting. This whole threat modeling activity helps bring clarity to the whole design of misattribution solutions. It makes it very clear what are the important risks. It helps you focus your time, money, and effort on the mitigations that really matter. It helps make clear where architectural changes need to be made, and it makes sure that everyone is on the same page about the risks that you have chosen to accept. And let's face it, there are always risks that you are choosing to accept at the end of the day. Now, this has been abstract, so in the next 2 episodes of this series, I'm going to take a look at 2 specific, made-up, managed attribution solutions and misattribution operations, and walk through how I would start to look at threat modeling those 2 specific cases. Thanks for watching. I hope you found this episode interesting and useful, and if you did, please like and subscribe, and then click the bell icon to be notified each time new episodes are released. We upload new content every other week, and we'd love to hear from you. Let us know down in the comments what other topics you'd like to see us address. Till next time, ciao!